Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. In this lecture, we are going to discuss about in detail about the various industrial applications for the reverse osmosis. Reverse osmosis also provides its potential as a downstream separation process in various food industry and biochemical industry. Other use of RO include the removal of organic salt and silica of deionization in boiler feed water, then removal of inorganic salt, phosphorus and nitrogen compound in municipal wastewater treatment, and also demineralization of seawater and brackish water in production of potable water. So in this session we are going to discuss about the desalination of brackish water, natural color concentration, concentration of landfill leachate, concentration of fruit juice, concentration of digested sludge liquid, dewaxing of lube oil, processing of crude oil or feedstock, and various other applications for the reverse osmosis. So let's first start with desalination of brackish water. With increase in industrial activity, water requirement for industrial use as well as for drinking purpose is rising day by day. The salinity of groundwater has also increased due to the various reasons. Even fishing boat, ocean liner and submarine also carry reverse osmosis unit to obtain potable water from the seawater. In brackish water, where the content of sodium chloride is a much less than seawater, lower osmotic pressure should be overcome for the desalination. The reverse osmosis process is also being used in conjunction with microfiltration to produce ultra pure water for the manufacturing of semiconductor. Schematic diagram for desalination of processed water by reverse osmosis shown in this figure. The typical reverse osmosis system consists of pre-treatment, membrane assembly and post-treatment. Pre-treatment of reverse osmosis is important because of need to maintain high quality of clean membrane surface. As such, solid with the water must be removed and water is give treatment to prevent salt precipitation and bacterial growth from the occurring on membrane. The pump supplies the pressure need to push the water through the membrane. Even the membrane rejects the passage of salt through it. Typical pressure for brackish water is range from 225 to 375 psi, or can say that 1.6 to 2.6 megapascal. In case of seawater, the range from 6 to 8 megapascal. The membrane assembly consists of pressure vessel with membrane that allow to feed water to pass against it. The membrane must be strong enough to withstand whatever the pressure is applied against it. Reverse osmosis membranes are made in various configurations with two most common configurations, spiral bound and hollow fiber. So in this desalination treatment, first pre-treatment are used, then reverse osmosis membrane are used for the separation process, and post-treatment are used to stabilize the pH level, and we will get the desalinated pure water. So it is necessary to pre-filter the brackish water, because if we are not going to purify this brackish water, we will get accumulation of solute on membrane surface, and which result in concentration polarization and fouling. So it is required to first pre-filter of brackish water, then we will get some amount of pure water that pass to the reverse osmosis membrane assembly, and again it pass for the post filter to stabilize the pH of the water, and we will get pure water as a product in permeate. So this is all about the desalination of brackish water. Now let's discuss about second application of reverse osmosis, which is a natural color concentrate. synthetic colors are being banned for use in food and beverage preparation. Attempts are being made to develop natural color. The natural color used in food industry are anthocyanins, vitamins, and carcinogens. Natural color contain the colorant from 0.1 to 0.2% and 6 to 8% of dissolved solid. RO process can be used to prepare high concentration of natural coloring material for more practical industrial application. So, in natural color concentration, the concentration are required where we are mostly used for the distillation, vacuum distillation as a conventional process. But if we are going to replace this distillation, evaporation or vacuum distillation by the membrane separation process, we will get advantage of energy saving and high purity. So if we are going to replace this equipment or can say that distillation with membrane separation process, first feed have to add to the reverse osmosis assembly, then concentrate will be rejected which used for the color purpose and water that can be used for the other purposes. So we will get concentrate as a rejected from the reverse osmosis and will get pure water from the permeate which used for other treatment or other purpose. So in natural color concentration, first color are pesticide, then concentration of that color occurs. For the pre-treatment, then concentration of color is used. Then we are going to add other constitute for the maintain pH and we are again pesticize the material and go for the bottling and packaging purpose. So this is how reverse osmosis used and beneficial for the natural color concentrate. Now let's discuss about concentration of landfill leachate. Landfill leachate is a highly variable feed solution that present particularly difficult treatment challenge, especially when high effluent quality is required. It is a complex solution consisting of four general type of pollutant such as organic compound, dissolved heavy metals, organic and inorganic nitrogen, and total dissolved solid which known as the TDS. Two commercially available treatment processes that are able to efficient removal of TDS from wastewater are mechanical evaporation such as vapor compression, vertical tube falling film, horizontal tube spray film and forced circulation are used for this mechanical evaporation. And second which is a membrane separation process. A comprehensive evaluation of vapor decompression mechanical evaporation and reverse osmosis so that reverse osmosis can be a very effective in treating of landfill leachate concentration. So let's discuss about how the reverse osmosis used for the concentration of landfill leachate. So in concentration of landfill leachate, pre-treatment done for the leachate, then it's go to for the aeration tank where the air is passed from in aeration tank, then it pass for the ultrafiltration where the pre-treatment of this mixture is occurs, then it will go for the reverse osmosis or nanofiltration. Mostly reverse osmosis are used for the concentration of landfill leachate. If the TDS and other particles are less level in the mixture then nanofiltration are used. Otherwise we can go for the reverse osmosis and we will get the pure water. So this is how the concentration of landfill leachate is used. First for the leachate is passed to the storage basin, then pre-treatment of that leachate is occurs, then physical and chemical treatment used for the remove solid particle and other physical waste, then it go for the biological treatment where the aeration tank and other process are used to remove the organic material, then it go for the ultrafiltration. It is necessary to use ultrafiltration as a pre-filtration for the reverse osmosis. Then it's go for the reverse osmosis, then concentrate leachate. We will get the concentrate leachate and treated leachate. If we are get concentrate leachate, which recirculate to the landfill, and if we are get the treated leachate, which used for the further use. So this is how the reverse osmosis used for the concentration of landfill leachate. Now let us discuss about concentration of digestate sludge liquid. Sludge produced in wastewater treatment facilitated are most often treated in anaerobic digester for further degradation of recalcitrate organic solid for the stabilization of centrifuge which produce concentrate biosolid and liquid which known as a centrate. The centrate contain high concentration of nutrition such as ammonia, orthophosphate, organic nitrogen, then heavy metal, TOC, TDS, color, and TSS. The common practice for the centrate treatment is return it back to head work for the wastewater treatment facility for the retreatment. When these species are returned to the head of treatment facility, they increase the facility loading and operating cost, and it is suspect that some of the constituents are end up in effluent as a nitrogen and phosphorus species. Reverse osmosis can be used as a potential process for the concentration of centrate. However, reverse osmosis and the centrate is pre-treated by the filtering it through 150 mesh sieve. Water is then extracted from the pre-treated centrate using cellulose triacid reverse osmosis membrane and NaCl draw solution. So for this, the forward osmosis process are used where natural separation occurs due to the forward osmosis phenomena. Then reverse osmosis are used for separate this draw solute or can say that dilute draw solute from the effluent. So this is how the reverse osmosis used for the concentration of digested sludge liquid. So this is how the reverse osmosis used for the concentration of digested sludge liquid. Now let's discuss about the dewaxing of lube oil. Conventionally, dewaxing of lube oil are carried out by solvent extraction. Here lube oil is a mix with solvent and mixture is cooled down to the 20 degrees Celsius, the temperature at which crystallization of wax take place. However, subsequent solvent recovery by the flushing and stripping. However, subsequent solvent recovery by the flushing and stripping incurs the high cost. On other hand, reverse osmosis process employ silicon rubber membrane can yield better separation when fluorinated siloxane polymer is used for the membrane material and high flux and better selective are achieved. Now let's discuss about the next application of reverse osmosis, which is a processing of crude oil feedstock. A variety of polysulfone membrane are used for the processing of feedstock by the reverse osmosis. The product of this process is a permeate that is equivalent of gas oil and concentrate enriched in asphalt. However, because of the high viscosity of the crude oil, the separation is carried out at temperature range of 50 degrees Celsius to 80 degrees Celsius. So this is how reverse osmosis is used for the processing of crude oil feedstock. Now let's talk about the various other applications for the reverse osmosis. Reverse osmosis can be used for the recovery of valuable product from the wastewater stream. Some of specific applications include treatment of electroplating rinsed water to recover metal in which treated water attain suitability for the reuse. Then it's used for the removal of metal from cooling tower blow down water, and it's also used for the purification of pulp and paper industry effluent. So this is how the reverse osmosis is used for the other application. So in this lecture, discuss about various industrial applications for the reverse osmosis such as desalination of brackish water, concentration of digested sludge liquid, natural color concentration, concentration of landfill leachate, dewaxing of lube oil, and processing of oil feedstock. So these all are applications for the reverse osmosis. So this is all about today's lecture. In next lecture, we are going to discuss about the nanofiltration and concept of nanofiltration. So this is all about today's lecture. I am completing my lecture here. Thank you.